We often assume that we are the first technological civilization to arise on Earth. And perhaps we are. But what if we're not? How sure can we really? One of the most famous ways to estimate how common life is in the universe is the Drake equation. It calculates the number of intelligent civilizations in the Milky Way with which we might be able to communicate. Among the variables are how many stars have planets, how many planets are habitable, how often life arises, how often it becomes intelligent and technological, and finally, how long s. Today, we know there are billions of potentially habitable planets in our galaxy. But for most of the other variables, we have only one data point, us. And when it comes to extinct civilizations, we have none. At least, not yet. Now here's a curious thing. If we ever discovered even a single trace of life, past or present, somewhere else in the universe, it would radically shift the equation. But even more fascinating, if life arose independently multiple times on Earth, it would suggest that life emerges easily under the right conditions. There's a possible hint of this. In Western Australia, a 4.1-billion-year-old zircon crystal was found containing carbon with a chemical signature that might indicate a biological origin. If that's true, it would mean life appeared very early on Earth, vanished, and then re-emerged again. In other words, life might be resilient and fast to return. But finding evidence of life from that long ago is nearly impossible. Why? Because Earth's crust is constantly recycled. Plate tectonics pulls surface material back into the mantle in a process called subduction. Over hundreds of millions of years, almost all surface rock is destroyed or transformed. Only the rarest bits survive. Which raises a provocative question. If a technological civilization had existed millions or even hundreds of millions of years ago, would we know? Probably not. Modern humans have existed for about 300,000 years, but large-scale environmental impacts began only in the last 10,000. And industrial civilization, cities, factories, machines, has been around for just a few centuries. If we were to vanish tomorrow, most of our structures would erode and decay within thousands of years. In a few million years, nearly all evidence of our presence would be gone. Fossils? Rare, even for dinosaurs who ruled Earth for 180 million years. We have only scattered remains. Our industrial footprint is tiny, and it's limited to a very small fraction of Earth's surface, less than 1%. So what would survive? Geochemical traces. For instance, nuclear weapons testing has left behind long-lived radioactive isotopes. Our industries have released heavy metals, rare elements, and artificial compounds like plastics and fluorocarbons, none of which occur naturally in significant amounts. These may end up locked in sedimentary layers. Another clear sign is climate change. Humans have released 500 billion tons of CO2 into the atmosphere, changing the ratio of carbon isotopes. This shift will leave a fingerprint in ocean chemistry, soils, and geological strata. Future geologists may one day study a thin layer in the rock record, a brief, strange chapter where carbon spikes, temperatures rise, and new chemical compounds appear. That's the Anthropocene, the proposed geological epoch shaped by humans.